Professor David C. Geary is a prominent cognitive scientist and psychologist at the University of Missouri. Currently, he is the Curators Distinguished Professor, which is the highest, most prestigious academic rank awarded by the university for his extraordinary research, teaching, and professional achievements. He published more than 330 articles. He lectured in various university departments: anthropology, biology, behavior genetics, neuroscience, physics, a few of them, across US, Canada, Europe, and East Asia. Please welcome Professor David C. Geary. Thank you for joining, Professor Geary. How are you today?
I'm doing well, thank you. I hope you're doing well.
Yeah, thank you. Thank you for your time.
hmm
So, straight to the topic, our evolutionary origin of mathematical mind. So, my first
hmm
question as a layman is,
hmm
what is maths?
Right. Well, good question. We have kind of an intuitive inborn sense of relative quantity. So if we see a bunch of fruit over here and some other fruit over there, we can kind of tell which is more and which is less. But that's not the same as formal mathematics. That is, arithmetic, algebra, geometry, and so forth. And formal mathematics is evolutionarily novel and a relatively recent cultural invention, maybe somewhere between 5 and 10,000 years ago. People began to develop symbols to represent quantities, and then later operations to manipulate quantities, like add them or multiply them or whatever. So it's a recent emergence in our history, and only emerges in certain cultural contexts.
Right. So that means it's kind of like a constructed thing, human being made up, not made up is the right word, kind of evolved, human being kind of made these things up. Is that the right, or constructed these things up? It's not a natural universal thing.
Right. I think made up is about right. They invented systematic ways of representing and manipulating quantities, but mathematics as we know it today emerged from the work of lots of people over the course of many thousands of years to build up this body of knowledge now that we teach students in standard schools. So most of it is in fact made up or constructed and refined over the last few thousand years.
So what is the thing like we learn? Okay, I mean, I understand a little bit about biologically primary knowledge, which is coming from the
hmm
society and our day-to-day living, and the biologically
hmm
secondary knowledge, which is kind of we are learning like mathematics and education in schools and stuff.
hmm
So when a child looks at a dog, what does it encode as a knowledge that
hmm
this dog is different from a cat or a building?
Right.
And and
Yeah.
and where does this encoding happen?
hmm Yeah, I've made the argument that a good way to think about schooling is to separate biologically primary knowledge or more inherent cognitive systems from culturally specific ones. So, language, for example, would be a primary system that is a universal. It requires exposure to language and early language development and so forth. But every kid is going to get it, no matter where they're at. The ability to navigate from one place to another is another kind of primary type of skill that's universal. It doesn't need any formal instruction. All kids need to do is engage in normal species typical activities like talk to their friends, talk to their parents, and so forth, explore the environment. And these competencies, these primary competencies, become fleshed out and adapted to their local context. However, things like reading, writing, mathematics, a number of other things, academic physics, for example, all of these skills are only emerge in certain contexts, and specifically in contexts that require students to take a lot of formal instructional coursework in those areas. So the knowledge of a dog, as you said, basically comes from experience. Dogs are in the natural world like other animals are in the natural world. And we have a system in the temporal cortex that gives us, allows us to encode experience with dogs. We have enough experience with dogs. We begin to generalize, kind of come up with a broad concept of what a dog is, that has four legs and is sociable and so forth, barks, whatever that might be. And we have experience with cats, and with enough experience with enough cats, we generate a general concept of cats. And once we have these general concepts, kids will begin to understand that they're different in specific types of ways, dogs generally and cats generally in specific ways. And that's a natural system. So anything that you have frequent experience with will result in this conceptual understanding and this conceptual knowledge. Now, that's true of mathematics as well. The problem is, in order to understand mathematical concepts correctly, you have to have a specific pattern of experiences. You learn numbers and what the quantities they represent, and move on to addition and so forth. And those experiences have to lead to mathematically correct conceptual understandings. So, for example, kids in some textbooks in some countries, kids see addition problems like 3 plus 5 equals what? Or 7 plus 4 equals what? So the addition is always on the left and the question mark is on the right. And then they see the equal sign. And a lot of kids then interpret that, well, what's common across all these problems with the addition on the left and the answer going on the right is that the equal sign is that you solve the problem. So the equal sign means you solve the problem. Doesn't mean mathematical equality, that the quantity on the left has to be identical to the quantity on the right. And so if you only present problems in one particular way, kids will learn a concept. But if you don't present problems in ways that force them to understand the concept in all sorts of different contexts, then they get the wrong concept. So in this case, you would have 3 plus blank equals 8. So now they have to understand, that you have to make the sides equal by putting in a 5 on the left. And that forces them to understand that, well, no, the equal sign doesn't just mean solve the problem.
Then, like how this happened, I mean, I'm taking like extreme example, like someone is thinking mathematically about black hole and someone
Mm-hmm.
is struggling to understand just, bare number crunching. How that conceptually, like someone is like so far ahead happening.
Mm-hmm. Right. So to conceptually understand a black hole and mathematically understand it, you have to have huge amounts of training and experience in mathematics and in physics. So you can't go from number crunching, basic number crunching, to understanding a black hole. You don't get that concept unless you've had a lot of prior knowledge and experience to get that. So, let's go back to primary things in language. So language development is based in part on experiences, but evolution has done half of the work for kids. There's a brain network and brain regions that are automatically going to pick up language sounds and begin to put them together into sentences and so forth and help kids understand what they mean. So they need some experience, but evolution has kind of pushed them halfway or more there. With a black hole, there's no built-in brain systems that automatically allow people or naturally allow people to understand a black hole, especially mathematically. It's a super abstract concept. And so Instead of starting at 50% when you're born, for language, for black hole stuff, everybody starts at zero, and they have to build up through educational and other experiences during their lifetime. And most people aren't going to get to that point.
In your paper, you talk about folk psychology. Okay, can you
Mm-hmm.
please explain that? Or is it a general intelligence you mean by that?
Mm-hmm. No, I see them as different.
Okay.
For primary abilities, I break them up into folk psychology, folk biology, and folk physics. Folk psychology are cognitive abilities and underlying brain systems that support social competencies. So language, understanding and being sensitive to facial expressions, theory of mind, the ability to make inferences about what other people are thinking. All of these are human universals, partially built in and partially fleshed out with early developmental experiences. So the psychology part is the social part. The biology part is understanding other species like dogs and cats with enough experience. And folk physics is the ability to deal with the physical world, like navigating from one place to another, or thinking about how a particular object might be used as a tool.
Now I'm going towards one of another part of your work, which is the sex differences around it.
Mm-hmm.
So
Sure,
definitely not ideologically, but analytically, which cognitive
sure.
differences between male and female are most robust in mathematical domain?
In mathematical domain. Yeah, that's a great question. So
And
if
and and
we,
sorry, Professor, one
Mhm.
thing. And
Sure.
is it kind of a societal or historical or evolution? Because like there are a significant amount of time there was no education in uh,
Hmm.
female clan,
Yeah,
so to speak. So
mathematics.
yes.
Yeah. So if we look at just average math achievement scores, like you take a regular math achievement test, sex difference is pretty small. Usually guys do a little bit better, but not by much. And it varies across countries. Some countries girls do better, other countries guys do better, and so forth. If we look at specific competencies, boys and men uh, are reliably better in math domains that involve a spatial component to it. So that would be areas like geometry, areas that involve sketching out mathematical relationships or visualizing mathematical relationships. So word problems would be one example there. If you look at sex differences outside of the spatial domains, they're much smaller. Sometimes girls do better, sometimes boys do better. So I think it's primarily the ability to use visual spatial abilities, which is a folk physics competency that boys and men are better at, to understand mathematics and use those to solve mathematical problems. That's basically where most of the differences reside.
So it's nothing societal or historical. It's just that boys biologically born with that spatial extra capacity.
Right. Yeah. So girls are better at some folk psychology things, and boys are better at some folk physics things. So boys have an advantage in visual spatial things that are evolutionarily related to things like navigation, visualizing how to use objects as tools, and other types of things. In an educational context, those same skills can be adapted to solve certain types of math problems, like geometry, for example. So the guys didn't evolve a better sense of mathematics. They evolved other skills that can be used in mathematical contexts. So for girls have advantages in language skills, for example, and that gives them advantages in academic domains that are based on the language system. That would be reading and writing. So girls didn't evolve to be better writers than boys, but they evolved a better integrated language system that makes learning to write and being a good writer and learning to read easier for them than for guys.
Okay. why or how does this maths anxiety comes, or why that exists?
Sure. Yeah. Yeah. Good question. So, so mathematics is evolutionarily novel. So, from that perspective, there's no built-in math anxiety. There might be anxiety about spiders, for example, that's more built in or easy to trigger, but math is different. So, I think what's going on is you have some people who have higher levels of trait anxiety. They're just generally more anxious than others. And then you expose them to things that make them anxious, like mathematics tests, and they then begin to develop a type of phobia around that area. So it's a learned, it has a learned component to it based on probably a biological propensity to get anxious about things that are potentially threatening.
Mhm. So that way, like physics anxiety also exists
Mhm.
probably, but we
Sure.
don't talk much about it. Is that right?
Yeah, yeah, that's right. And from that perspective, you can develop anxiety about anything that you're required to do and find it hard to do or threatening, or you're worried about being evaluated or whatever. So there's a reading anxiety as well. Uh, People, probably more boys and guys, can develop anxiety about being asked to read in a school setting, for example, than girls, because it's more difficult for them. They make more errors and so forth.
Mm. I'm also like that. I now I can realize I have a bit of a reading anxiety. Okay.
Yeah. Yeah. The way to get over it is to do more reading or to do more math and build your fluency and stuff, and then the anxiety will lessen.
So that is normal to build up your resilience, whatever way it's possible.
Yeah, yeah, exposure to it. You become exposed to it for math. You build up your basic skills where you're practicing in areas where you're pretty good at, so you're not going to make a lot of mistakes, and you get better at the basics, and then you get better, and your anxiety will reduce for the basics, and then you can build up more complex skills in math, and your anxiety will reduce there. Just like with reading, if you read a lot more, especially difficult text that would probably take some effort, your anxiety, as you get better at it, your anxiety would begin to go down.
This is typical Indian question because in Indian
Mm-hmm.
education system there was a massive emphasis on practice, practice, practice.
Mm-hmm.
Where in Australia, when my kids are going to school, it's all about how problem solving it is or how experiential learning it is rather than practice, practice, practice.
Mm-hmm.
I mean, which is
Um,
better, which is not better? Any research on that?
yeah, I think India's got it right there, especially for something like mathematics. The irony is that the experiential, the focus on child-centered learning and internal motivation, experiential sort of thing works beautifully for biologically primary systems. So you don't have to tell kids, well, you need to learn your language. You're not going to be able to talk to anybody when you get older. They have a built-in system for it. They have a built-in motivation to engage their parents and later their friends socially. And just by doing that, they're building up their language competencies. But when we get to secondary things like mathematics, there's no inherent motivation, no universal motivation for kids to study mathematics and to learn it. And not only that, when we look at this conceptual learning system that I talked about previously, about for dogs and cats, and it also is engaged for mathematics. The only way you build up that conceptual knowledge is with lots of experience in that domain. Now, for social domains, you can have everyday experience. Kids are going to play for hours and hours and hours. They're getting all sorts of experience. They're learning all sorts of things, but they're not getting hours and hours and hours of mathematics. experience through their natural activities. And so the irony is through practice, you and building up basic skills slowly and systematically to make sure kids learn the right concepts, that like with equality, that they're not making the wrong inferences, they eventually develop a conceptual understanding of that mathematics. And then they can take that conceptual knowledge and use it in other domains. What you're talking about in Australia is an attempt to build in that conceptual knowledge without going through all of the boring practice that this evolved conceptual system requires for it to develop. So what you have in that situation is you have kids who can memorize a concept. Equality means, the two sides are equal and blah, blah, blah. But then they make mistakes when you give them problems like 5 plus blank equals 10, which means they really don't understand the concept. They've just memorized the verbal definition of it, but their conceptual learning system has come to a different conclusion. And so it is like, if you want to get to where the folks in Australia want kids to be, you can't skip all of this systematic practice.
That means more exposure to many things, kind of enhancing your biologically primary knowledge, repetitive exercise, tasks, kind of enhancing your secondary knowledge. If you are enhancing your biologically primary more, will that kind of help to absorb this more, or more practice kind of help to absorb this one more, or they are exclusive?
Yeah. Good question. I think it's better to think of them as separate. I mean, they interact with one another for sure. There's no question about that. But the question is, what types of experiences does it take to build up secondary knowledge like mathematics versus what types of experiences does it take to build up primary knowledge like social skills? And the fatal flaw in educational theory is they think that the types of experiences that build up primary knowledge, like playing with your friends, exploring objects, and whatever case might be, will automatically be the same types of experiences you need to build up secondary knowledge. So this played out with the whole language debates and reading. So it was thought that literacy was a continuum, starting with babbling and then language and so forth, and moving on to reading and writing. And they assumed that the experiences that facilitated language development would be pretty much the same as the experiences that, if those same experiences could then be applied to learning to read and write by providing books to kids and with pictures in them and all of that. That's because they didn't make the distinction between an evolved and non-evolved trait, and they made a fatal error and undermined the reading skills of a lot of kids.
So does this modern education amplify or suppress these natural cognitive differences between boys and girls?
Well, it can do both, just depending on that. So I mentioned that girls have an advantage in reading development because they have advantages in part because they have advantages in language. And so they do better on phonemic awareness, understanding that ba, pa, da, ka are basic language sounds, and you can associate them with the associated letters. Girls are better at that. Now, you can equalize things, but you would have to give boys more practice and experience, or a lot of boys would need more practice and experience to get up at the same level as girls. So you can equalize those, but you would have to treat them, boys and girls, differently. Same thing with math and spatial types of things. You can do specific interventions to teach girls to specifically use spatial strategies to solve problems, which would reduce the difference. More boys and girls are naturally kind of falling back on these spatial strategies, but you can teach them to girls. So in those cases, by treating boys and girls the same educationally, you're getting bigger differences. But if you had somewhat treated them a little differently educationally, you might have smaller differences in certain areas. And in some educational systems where in secondary school or high school, where boys and girls, students are kind of can pick and choose what track they want to go on, a science and math track, humanities track, or they pick their own courses with that type of kind of liberal educational structure. Boys and girls often focus on different types of coursework. Girls focus more on reading, writing heavy courses, and boys more on math, science heavy courses. And because they're beginning to take more courses in different areas, their underlying differences get bigger. If you had a set curriculum for everyone, they wouldn't be as big.
Another major thing you talk about, which is language and culture. So
Mm-hmm.
how does language structure influence early number processing? And are some languages help more to understand numerical cognition and some are less? How you see it?
Yeah, there are some language influences on basic numerical skills. So a lot of the first number skills are counting. You know, 1, 2, 3, 4. You memorize your culture's list of words, number words, so forth. Some language structures help kids understand numerical magnitude better. So in some cultures, you know, like Japanese, 20 would be 210, 21 would be 210, 1. And so the quantity represented by 21 is by that number word is transparent. It's clear. 11 is 10, 1, 12 is 10, 2, so forth. In English, it's 11 and 12. The underlying base 10 structure of that 11 is 10 plus 1 more, 12 is 10 plus 2 more, is not at all transparent. And that makes kids' early understanding the quantities represented by those number words more difficult in English than, say, Japanese. Same thing for fractions words. So, 3/4, you can kind of know that, but in some languages, it would be 3 of 4 parts, something like that. So the description is much more transparent and easier for kids to understand.
Okay. So mathematics is basically kind of we are acquiring with our effort and all these things. So we
Mhm.
need support. How much support is too much support, or how much is not too much?
Right. Yeah. So John Sweller's talked about this. You know, if you have a lot of knowledge in a particular area and you give too much support, it kind of can undermine your performance because you're distracted by the support stuff. But when kids are first learning things, they need a lot of structure and support. So for language or visual spatial skills and other types of skills, there's built-in systems that are automatically processing the relevant information. And kids engage in experiences like social interactions that naturally provide the experiences they need to fine tune these evolved brain systems and adapt them to their local conditions. But there's no, as I've said before, there's no built in structure for mathematics. And so all of the experiences in the structured experiences that will promote mathematical development have to come from textbooks, instructional materials, teachers, and so forth, because evolution hasn't already done half the work for you. You have to kind of put it in there, and you need to do it in a way that is organized to make sure that kids don't come to the wrong conclusion about mathematical concepts, such as the equality one that I just mentioned.
So sports,
Mm-hmm.
any kind of sports or any kind of play, because
Mm-hmm.
children normally like it and adults, many adults also like it. Are
Mm-hmm.
they primarily biologically primary or secondary?
I would say a lot of it is primary, and it is organized activities. Kids play and they do all sorts of things. They do group level play, so like playing soccer together or whatever. You're learning to coordinate your activities with your friends to better compete against other groups of guys. Now, soccer in itself isn't important. That's a cultural feature, but you see similar types of group level competition as part of play across cultures, although, one place it might be soccer and one place it might be something very, very different. And you use pretend play to understand the roles that different kids can take or different people can take. You play house, you play cowboy and Indian or whatever it might be, warrior fighting a dragon or something like that. So there's all sorts of different types of play that build up certain types of skills. The surface structure can differ across different cultures, just like the languages can differ, across different groups. But the basic underlying structure is similar.
You talk about different type of self, like private self, projected self, extended self. Can you please explain that a little bit? And from that, I
Yeah.
have a last question.
Okay. So you might be thinking of an article I co-authored a couple of years ago on self-awareness and as related to academic competencies. So, generally, we're kind of aware of our environment and so forth. But I think self-awareness is really the awareness of yourself as an individual, awareness of your individual traits, like, you're taller than average or shorter than average, or you're more sociable than average, or whatever it might be. So you have a level of insight about yourself that other species don't have. A chimp can recognize themselves in the mirror, but they don't probably know that, well, they're relative to other chimps, they're pretty extroverted or whatever the case might be. And so the question that is, so you become self-aware and you're aware of traits that are important in your culture, and how your traits kind of fit with that. And certain things seem to be universal. So awareness of one's social popularity, one's physical skills, athletic skills, for example, seems to be universal. And all kids want to think of themselves or want to be, athletic and sociable and have social influence, for example. That seems to be a universal. The thing is, when we get to academics, like reading skills or math skills or whatever, um, kids' self-concept in these areas, their understanding of themselves and their view of themselves, how good they are in this or that, is much more variable. So many, many kids want to be good socially and athletically and so forth. And some kids, want to have a good view of themselves as being good at mathematics, for example, but other kids don't care at all about it. And so um, we argue that, kids are naturally going to pick up a sense of, social competencies, athletic competencies, and so forth, just through their natural activities. But they're not going to really develop a sense of the importance, the cultural importance of mathematics or reading skills or writing skills or any other academic skills without a lot of cultural support saying, this is really important for you to learn. Because if you do well at this, you're going to have a much easier time as an adult than you would otherwise have. You don't have to teach kids those sorts of things about social skills or athletic skills. But you do need these extra structures in there to build self-esteem and concepts for these academically novel or biologically secondary skills. Does that make sense?
Hmm.
Yeah.
Okay.
But, Yeah, I don't know if that's not exactly what you asked, but it segues into the primary secondary stuff that we talked about previously.
All right. So the last question, which is again a little bit of philosophical.
Hmm.
So with acquired knowledge or with observing from our social structure and all, we are manifesting something to the outer world, expecting
Hmm.
that we will get reputation or power or some
Hmm.
sort of validation from external world.
Sure.
What whatever the reason it is happening, where this inflated ego and humility sits.
Right.
And
So yeah. So people are very conscious of where they stand relative to their peers. So, do they have an advantage in this area relative to their peers, or are they disadvantaged in relative to their peers? So, there's always a social comparison going on, and it's related to status in particular areas. And it's related to status in particular areas because if we look back at human history and evolutionary history and just the way things work across species, is higher status individuals are buffered from life stressors more than lower status individuals. And if there's a population crash, there's a plague hits, or there's a famine or something, the lower status folks are the ones that are going to disproportionately die or suffer as a result of that. So you need to kind of compare and figure yourself out and move up the status hierarchy as much as you can through prestige, developing skills that other people find valuable. They'll allow you to move up and are happy to move up because you're helping them. So that's important. But there are also some people who pretend like they have high status and high skills and manipulate other people into treating them like they were high status when they really don't have the associated skills. I mean, maybe that's what you're talking about. Maybe not.
maybe,
Okay.
maybe, but yeah, as a layman or as an outsider from the university or any structure, so to speak, people who are really kind of that elite league, we
Hmm.
find a lot of humility in them. And
Oh,
people who
sure,
are
sure. I
kind of
see. I see.
stuck in the middle, they kind of that inflated ego, a
Oh,
power
I see.
fetish, and all these things.
Right. Yeah, yeah, yeah. So somebody who's elite and is socially recognized as being elite has already made it. They don't need to bluff their way to a higher status. Somebody who's in the middle and ambitious and wants to move up, in some contexts, kind of bluffing and acting like, yeah, I know how to do this and I know how to do that, and I can organize us better than this other guy, whether or not they can, is a way for them to try to socially climb. Now, they may fail at that and then they'll fall back down, but for a while at least, it will give them some type of advantage.
That means you were talking about this all comes down to that social hierarchy. In some
Mm-hmm.
cases, who is elite in one
Mm-hmm.
ecosystem, everyone is seeing elite. Maybe he or she in another ecosystem, maybe in the bottom of the pyramid.
Right. Yeah. Yeah.
So
Depends
there
on.
maybe he is not behaving that with that humility.
Yeah, probably somebody who's a lead in one area, if it's a socially important area, won't care as much about other areas where they're a lead. So if you have a, world-class mathematician, they get plenty of self-esteem and money and fame or whatever from that. And it doesn't matter that they can't sprint very fast. It's not important to them. And it will work the other way around. Maybe, a world class athlete, yeah, wouldn't really care that he's not really that good at algebra because they get enough praise and social respect and so forth from this other domain. But it has to be a domain that's culturally valued.
Is it like a validation from the outer world they are behaving with
Hmm.
humility, or it's there
Hmm.
from inside that, okay, we have achieved what I wanted. That's
Hmm.
why they are acting with humility.
Yeah, I think it's a little bit of both. There is a component of personality that's, partly heritable, maybe 40% or so. That is humility, that some people can be high status or middle status, and they're very modest about it. They don't brag and so forth. And there can also be very high status people that do brag and say, well, I'm better than you at all of this and so forth. So it has a component to it. But I think a lot of ambitious people, when they make it and become, they're getting the esteem and money or whatever it is that is important to them, then they can be a little more humble. And in fact, higher status folks being more humble is a way of um, reducing the chances that up and comers will attack them. So if you're at the top, there's always somebody just below you who's going to want to move up. And by being humble, it's a way of kind of uh, maybe preventing that a little bit, or at least if you do get attacked, you've got other friends and they're going to support you. Where if you're a narcissist and bragging and all of that at the top, you get attacked. A lot of other people are going to be very happy to join in and attack you to try to bring you down.
Man, that means what? We a really good people, or
Yeah, I think most people are good in most contexts. I mean, most people are cooperative and so forth, but there's always a social strategy to it. You can be good and cooperative and so forth, and it seems selfless, but it's really in your best interest. If you help other people and you're cooperative and so forth, you build a social network. You build a social support network of people who are going to be happy to help you if you get in trouble. If you're just selfish all of the time, you alienate everybody and nobody's going to help you if you get in trouble.
hmm, okay. So last question, what is the future of maths? I mean, I'm talking about abstract maths.
Yeah, so I'm not a mathematician, so can't say, but I think probably one mathematician told me once that more math had been invented in the last 100 years than had been invented in the thousands of years prior to that. So there's professional mathematicians and lots of universities around the world. A lot of them teach, but a lot of them do research. Their job is to come up with new ways to use mathematics, either abstractly to build theories or to make certain applied systems function better. So math is always growing as a field, just like physics is and a lot of other academic domains.
On that, we should end here. Thank you, Professor. Thank you
Okay.
for your time.
All right. Thank you for the great questions. I appreciate it.